In this video, we're going to be talking about shorthand argument names with regards to closures, all right? But we're also going to be going through high order functions. We're also going to be showing you how to sort collections, okay? And we have here a collection of integers and we have here a collection of strings. Now, in the last 60-something videos, I haven't actually taught you about collections. However, this one's going to kind of give you an insight to what collections are. It's going to teach you about high order functions, which you've already seen. It's going to teach you about closures, which you've already seen. And it's going to now teach you about shorthand argument names. And if you haven't watched the previous video, then you would have seen them in that video slightly. But this video is going to pack that all together, and we're going to show you how to do this. So let's first of all show you how to iterate over the scores, right? Well, we've seen this in another video. So let's just go bit by bit, all right? And we've got a score, and then we're just gonna say here, I'm gonna show you by demonstration first, then I'm gonna explain it afterwards. So as you can see here, we have iterated over each score. 21, you see here, score 21, 88, 50, 76, 82, 71. So this, what's happened here is it's gone through each item in the scores collection one by one, and it's printed out that one score in the console, all right? And this is basically what iterating is. We are iterating over it, and this is then a for in loop, okay? So let's now remove this for in loop, and let's do it another way using high order functions. And so we're going to take scores, which is a collection of type integer, right? The element is integer, and that has a couple of extra functions attached to it. And for this, we're going to say for each. For each is basically a for in loop, but it does it a little bit differently, okay? The outcome is going to be the same, but it just does it a little bit differently. So here we're going to say scores.for each, then it's going to give us a trailing closure, right? And then we're going to say then the score, and we're going to then print here the score, and we're going to say the score. And when we run it again, you get exactly the same thing. So now what you've seen is, this is scores.for each, or the for each is a function that takes a function. This is a high order function, and what we've given it here is a closure. And as we've seen in the other videos, we can say print score, and this can take a num, can take an int, and it can be void. And then we can literally place this in there as well, and we put that there as well, score, and let's just put num, and we can replace this scores for each with print score, and it will do exactly the same thing, all right? And we run it again, you see it does exactly the same thing. So this is now a function doing the same thing, but we now have a trailing closure as well. So let's get rid of that. We've seen functions and we've seen closures, but this is closures now being used. Now, but we wanted to understand how to sort these. Well, scores has, collections, they also have a sort high order function too, but in order to sort these, we've got to change it from being a constant to a variable. We've got to be allowed to change it. Now, if we look at the declaration of it, you can see that it doesn't return anything, so it's mutating, it sorts it in place. Now, we can also have another one which is going to return, which this is then sorted. So we want sorted, which this doesn't mutate the collection in place, which is what is better. So we're going to say then filtered scores here, or this is, so we wanted then ordered scores. So this scores.sorted takes a high order function, and it has two parameters. The first parameter is then an integer, then followed by another integer, and it needs to return true, all right? So let's just come here and we'll say then left and then right. And what we want to do is we want to say if left is more than a right. So we're just going to say return left is more than right. And we're going to print the ordered scores, and we'll remove anything else that we've got already, and we'll show you what the outcome is. Here you can see we are now ordering it in descending order. All right. Now, if we want ascending order, we just say if left is less than right, and now it will go in ascending order. Okay. So you can see 21, 32, 50, 71, 76. But this has, if we just show you scores as well, and we print ordered scores and scores, you can see that scores on the second has not been changed, has not been mutated. All right. Now, we wanted to know shorthand arguments. Well, we already know that it's got two parameters, all right? Or two arguments here. We've got two arguments here. And so we don't actually have to say the return keyword because we know that already. All right, let's just get rid of that. And we can then put this basically in line as well. And we can do it like this. This is fine too, but this is kind of duplicated. The compiler can kind of already infer how many, the compiler already knows how many arguments there are here. It knows it's got two. So we can remove that, but now the variable names, they don't have names anymore. Well, we can just say, hey, give me the first variable, and now give me the second variable. And it's zero index, so it means that the first one is already done by 0, and then the second is done by 1, 2 is done by, and so on. So now all we're saying is, hey, compare the first argument to the second argument. And we can run this once again, and you can see it all works. But what's magical about this is that we could actually just come here and remove this, right? And we could just put the underscore, the less than sign in here, because it already knows the less than or greater than sign. It's already implied that it has a left operand and a right operand here. So we can remove it outright. And this is the great thing about shorthand argument names, is that we can even remove shorthand argument names if we have an expression that is explicit. And less than or greater than is explicit because it has a left and a right operand, and this sorted method knows, this high order function knows it has a left and a right argument as well that can be put in the place of it. And we can then do it this way as well, and you can see that it still works perfectly fine. So this is a way of being able to use shorthand argument names. All right, now this has just been done by numbers, but what about if we change it to students too? And let's say ordered students here. And let's change this to students. And run this again. Now you can see Hank, Grace, Frank here. So that's then the ordered students. Oh yeah, sorry. The HGFEDCBA. Yeah, it's been ordered correctly. I got confused then. But if we do it then the other way around, you can see A, B, C, D, E, F, G, and H. All right, it's done it nicely. So this is working it out based upon the first letter. And if we added for example, and we'll say Andrew here, Thomas, for example, and we run it once again, you can see here that Andrew Thomas comes after because the N is after the L, so it sorts it based upon every single letter as well. So this is something really, really interesting that you can do, and it just goes to show you that you don't have to write lots of code. And if you understand closures and you understand all of their abilities and understand their syntax and their rulings about when you can use them, then it's a super powerful thing to understand. Now we've just scratched the surface of what closures can do. All right, there's a whole bunch more, and this is now just really showing you about high order functions, about what they can do. But when you start talking about like parallel programming, and if you start doing like iOS applications or macOS applications where you need to do things in parallel, you need to retrieve things from a server or from a database or something asynchronously, you are going to need to understand closures really, really well, because there's a whole bunch more complexity that we're going to add on to it. So if you understand it so far and you really understand it, then move on, all right? But if you don't understand it, then I would advise you right now to go back and start again and do a little bit more research, because it's going to get a little bit more difficult from now on. All right. Anyway, with that said, don't forget to like, subscribe, share, and do any other social media thing that you can do with this one video. If you do have any questions, feedback, concerns, or anything critiques about my instructional techniques, or whether I went too fast or too slow, or not in detail or in too detail or whatever, then let's start a conversation in the comment section down below. I will respond to every single comment on all of these videos. And yeah, I'm just doing it for you guys, people, to learn how to become a fantastic, competent Swift programmer. Thank you very much for watching. My name is David Thorne. See you in the next video. Ciao, ciao, and goodbye.